Hello, happy Sunday, everybody. I'll test my stream. Is everything okay? Video, audio, everything okay? Let me test that. I think it's clear. I'm able to hear myself clearly, and all right. Uh, yeah, the stream looks fine. It's clear. We have one chat. Vasanta Kumar R. Hi, Vasanta Kumar. Happy to have you. Happy Sunday, everyone. By the way. My apologies. Last week I couldn't make a stream. I was not feeling very good last week, so uh, I felt sick. So that's why I couldn't create any video last week. Uh, but no worries. We will learn something in today's stream, right? Uh, I have no idea literally. Earlier, I was building the Active Directory, very well. We had a couple of streams on building Active Directory. Actually, I'm learning the Active Directory attacks, what causes what makes that Active Directory vulnerable. So I've been learning those things. Those are all the basic stuffs that I need to learn. I'm a beginner. I'm a beginner to Active Directory attacks and also to the Active Directory itself. So I'm taking my time to understand how those attacks work. So until that, I won't be making any stream about that Active Directory building. But surely we are going to resume that Active Directory construction. We are just trying to build a vulnerable Active Directory, and hopefully we will resume that maybe in the upcoming streams, right? In today, what we can do, that's what I'm thinking right now. I don't have a concept today to make. Can I do any hack the box or try hack me machine live, or any other some other miscellaneous topics, or any uh, setup videos? I'm not positive what I'm going to do in today's stream. I have no idea. Maybe if you have any recommendations, you can give. I'm just letting it to my audience. I let my audience to decide. Maybe if you have any suggestions, you can give. Uh, if no, I'll try to choose what I'm going to do. Right. Let's see. I'm actually trying to take a concept to make a video. I have a lot of I'm just taking notes on every concept that I get for a YouTube video, for a YouTube stream. I'm just looking at the notes. What I can do. Domain controller we've already set up, and we set up one domain controller. We created a list of users, groups. We added the set of users into the group. That part we have done. But apart from that, how we can make that Active Directory vulnerable, that one we yet to do. As I said, we will do it in future streams. I'm learning through the hack. Actually, I'm learning with the Hack the Box Academy. In Hack the Box Academy, there is a module to learn Active Directory attacks. I've been learning that. So that's why I said I haven't accomplished that module. So once I accomplish that module, I got little confidence. I'll try to resume making that Active Directory vulnerable, right? What else we can do? I also thought to do some blue team stuff over the stream, like setting up an SIEM, an open source SIEM, and the EDR solution on my lab. But I need to plan that as well, because when you set up the SIEM and the EDR solution, you need to be aware of the hosts that you are going to monitor. That part, maybe I need to create a plan how I'm going to set my lab up, and how I'm going to monitor, what sort of events that I'm going to monitor. So those things and all I need to define. So I don't think it can be done in the stream. Uh, can I get any random blocks? Any interesting stuff? Let me grab a content for you. I can also do malware analysis. Hmm. Naughty Munda. Welcome stream. Uh, we got our opinion. Malware analysis. All right. Can we do a malware analysis then? Okay. We will try. We will try that. Then we will do the malware analysis. All right. Okay. We will do malware analysis. Fine. Let me check for my environment to analyze the malware. All right. It's been a while. It's been more than a year since I did the malware analysis. But anyway, for the stream's wish, I'm gonna try malware analysis. Let's see. But while doing, I need to be careful that I'm not detonating, or even if I'm detonating, I'm doing it in a controlled environment. Uh, I should make sure that I'm not uh, sending it to uh, any. I mean, I'm not affecting any other the other host machines. So that part I need to be careful. I think that's totally fine. Give me a second. Before few months, I did a malware analysis. I just refer. Give me a couple of minutes. So I need to refer that. Let me check. Okay. I think I don't have that notes with me right now. Do I have anything else? Let's just explore. Hmm. Okay. Let me grab a content. Actually, I took a lot of notes. I took a lot of bookmarks about every uh, post, every interesting malware, about the post about every interesting malware. So I'll refer that specific stuff and I'll get back. Give me a second. I'm gonna grab one interesting stuff to make blog. I think I made a couple of blogs recently. Let's see. Specula, Linux. I have managed video. I can CrowdStrike.exe. Okay. Trust, cyborg, DL hijacking. Uh, Give me a second. How to open a bookmark page in Chrome? Okay, like this. Let me grab that post. Let me grab that blog. Okay, I'm gonna bring an interesting content to you. So bear with me. Uh, Control Shift B. Let me try that. Uh, B, can I try like this? No. Control Shift O. How about that? Yeah, this one. Okay. Uh, Here I go to malware analysis, malware blog. Yeah. I go all the way down. Okay. I'll pick one interesting stuff. Recently we came across the CrowdStrike outage, right? The Windows outage caused by CrowdStrike update, right? This malware is related to that. So after that incident, hi Akshay TP official. Hi Akshay, thanks for joining. Um, in this video, let's get one malware. Actually, I took the notes of that. I thought to create a video about that. Maybe I'll just use that as a content to this stream, right? Let me go and grab that. I'll share my screen before I share my screen. Let me open that link to you. Where it is. Okay, I'll open that. All right, I guess I grabbed it. So let me share my screen now. Now you are looking at my screen. Let's see. We first learn about that malware. So I'm not going to do an unknown malware. I'm not going to do an unknown file to analyze. I'm not going to take that. But I'm going to take a known file. Maybe we already know its behavior. So anyway, I'm going to try to assess the same. Okay, just I've been doing it for a while. I mean, I've been doing it after a while, so I'm just gonna try a known one. And look at this: the fake CrowdStrike fixes target companies with malware data vipers. All right, you see, you are aware of that attack, not an attack, that outage caused by CrowdStrike on every Windows system that are using the CrowdStrike Falcon sensor, and it went out. It was showing the BSOD error. I think 1.5 months back, I suppose, to be precise. In August it happened. Not August. In July it happened. Now, after that incident happened, the threat actors actually leveraged that specific incident to lure their victims. So this blog is about that. About the threat actors' cunningness to exploit the victims of the CrowdStrike outage. CrowdStrike says it actively acting. Okay, I don't want all these things. Maybe I'll go and take that stuff, the malware. You see, on Saturday, cybersecurity researcher first reported a malware campaign targeting BBVA bank customers that offered a fake CrowdStrike hotfix update with Remco's rat. So actually, this behind this specific outage, the aftermath actually involved in many malware attacks like this. Not only rat, it also this incident actually used to distribute some vipers, data vipers. For those who don't know what is viper, I'll just give you a brief explanation. The viper is actually more notorious. It is notorious than ransomware. Ransomware authors, at least when you pay the ransom, there are some light chances to get your data back. But in vipers, there are no chances. The complete carnage. So it will lead to the complete carnage. It's all about the conspiration. The threat actor actually conspires against your business, and they just try to spread a viper to your into your network, and once it detonated, it will just erase, it will just overwrite all, it will just corrupt all the data present on your system. That's the only intention of that viper. So there is no intention behind that Viper other than uh, crippling their whole data. So that's the notorious stuff about the Vipers, and some Vipers also involve spread after this CrowdStrike incident. Uh, so you see the inherent tweet. I actually bookmarked it. You see the tweet here. As expected, the incident CrowdStrike has been exploited to distribute malware. In our example, so they actually mentioned a couple of malwares here. Hijack loader, which delivers Remco's rat. Remco's rat, who don't know, I'll explain. Remco's is actually a popular remote access Trojan, one of the popular remote access Trojans available. And the name of the zip archive, and you see the name of the zip archive is something they gave, and also they gave the link to that malware. All right, I'm not going to open this malware, download it in this machine. I have a separate sandbox for it. Maybe let me open that, and let's see. Here it is, malware analysis. Before I detonate, I open this VM. I need to make sure the network adapter is set to host only, and I also created a separate network for that, sandbox network. And I have two VMs here for the malware analysis. One is Remnex, reverse engineering and malware. I think reverse engineering malware, something related to that. And Flare VM, it's a popular VM, specially made for malware analysis. So it comes with the tools that are required for the malware analysis. Let's check the network adapter for that as well. Fine, I just chose the sandbox network. So these two machines are interconnected, but these machines will not communicate to the internet. That's a good thing. That's a good thing to have. Maybe I should somehow move this malware sample to the machine. But before that, let me check, do I have a snapshot for that? I do have a snapshot here. And what about the Flare VM? I do have a Flare VM fresh snapshot. All right, I'm gonna go and start one VM, but before that, let me read through this one as well. When seeking a fix, users affected by outage can destroy their entire systems. Attackers can now distributing a data Viper disguising the CrowdStrike update. It decimates the system by overwriting files with 0 bytes and then reports over Telegram. And look at this, an interesting one. So I'm gonna take this specific sample. I'm not gonna take that Remco's rat because that's widely being analyzed. But for the change, I'm gonna I'm a little fascinated about this Viper term. So I'm gonna take this one for our assessment today. So this is my sample. I can open this link and I can download the sample from any run app. Fine. Let me go to this. But before that, I'm gonna go and enable this network adapter. Maybe to NAT mode. That's fine. Just to have the internal connectivity for a few seconds. I'm just gonna go and enable this. Yeah, here is the Flare VM that I set. This is the password I set. I remember that. Yeah, I do remember the password. That's fine. Okay. I have the Flare VM now. And do I have the internet connectivity? It says no internet. But I changed the adapter. Let's see. Yeah, I do have internet connectivity now. Yeah, I have internet. So let me open this browser and grab that malware. So once I grab this malware, I'll go and turn off the internet connectivity. All right. Let me go to this. Maybe I'll create directory. I'm gonna go to this users malware analyst. Here maybe I'll go and create a folder like this. Okay, I need to download my malware here. Okay, before that, let me go and grab this link. So the Flare VM, the beauty of Flare VM is it comes up with all the required tools for the malware analysis. You can do both static and dynamic analysis in either way, in basic and advanced ways. So that's the awesome thing about this. Let's see. Still loading. It's taking its time. Let's wait. Okay, I think we got that. Look at this. So it does a lot of stuffs. Update 1.zip. That's the file name, and I can get the sample here by simply clicking it. Okay, I need to log in. So let me log in and come back. Let's see. I'm downloading the sample. Give me a second. I'll share my screen quickly. Let's see. Next done. I'm gonna go and open that one. Maybe I'll go to this users malware analyst malware. I paste here. Awesome. All right. Fine. I'm gonna go and log out. Yeah. Read browsing data, advanced, all time, everything I clear. Okay. All right, I have downloaded the sample. Now you are looking at that sample. Update 1.zip. That's the file name, and it's zipped file. So generally, the malware distributed from the AnyRun app is actually zipped. So you need to use the password infected to extract that archive. All right. Before I extract this, I'm gonna go and turn off the internet. Let's see how I can do that. Do I have an option to edit it? VM settings, maybe like this. Here, custom network, sandbox network. That's awesome. Okay. Now can I try to access the internet? So it says general failure. So which means the internet connectivity is gone. So we no longer have internet connectivity to this. I'll start the remnex parallelly. So the beauty of using sandbox is the VM is to analyze the malware. So once you infected the VM, you can simply roll it back to the previous snapshot that you took in a fresh state. So that's the interesting thing about this. Also, all right, I'll go and check this out. The Remnux. I'll be using Remnux also along with Flare VM. So if the malware initiates any traffic, any network traffic, I think I need to feed that malware with some network response. Maybe try to resolve some DNS names. At the time, I need to feed the malware with some response. For that, I might use the Remnux machine, which is in the same network. But these both Flare VM and Remnux are isolated. They are not connected to internet, but those machines are communicating each other. All right. Fine. I think it's okay. Can we go there? Users, malware analyst. Where is that? Malware. So is there any way to let me check like this? I'll move this to documents like this. Okay, now I have the file. I can unzip and I can start my assessment. Let's see. First of all, we need to begin with the basic static analysis. We need to use some utilities to assess what type of file it is. Okay. Let's see. Let's see. But before that, can I open terminal in Remnux? And let's see the IP address. Sorry, ifconfig. 10, 10, 15, 11. What about Flare? Ten, 10, 15, 10. So I'm able to ping the Remnux from here. Let's see. Let's confirm that. I'm able to ping. All right, that's awesome. I'm gonna go and create a directory, maybe sample like this. Sample. Okay. I'm gonna keep this sample in this Remnux VM as well. So let me go and initiate a web service, python 3-m http.server, just to transmit the file. I don't have Python. Okay, it's just Python, not Python 3. Awesome. Let's see. HTTP server. Now wget HTTP 10, 10, 15, 10, I guess. 8000. Yeah, it's available. Yeah, it's available. Now let me kill this and I go to documents directory, or maybe I'll come back one folder and go to documents, dir command. Yeah, here I have that path, and I do have that sample also, this one. Let's see. I'm gonna go and pull it. Okay, I'll rename it here. Update.zip like this. Now I pull it to this machine. Refused. Okay, because it's no longer hosting. Now I'm able to pull. Yeah, All right, we got the file now, update.zip. So let's unzip it and proceed. Is the Flare VM tool or firmware? It's actually a VM, a virtual machine, which is actually bundled with all the adequate tools for the malware analysis. So it's actually a VM utility, okay? A virtual machine, which is ready for malware analysis. So hope you used Kali Linux, Parrot Linux. So those VMs specially made for penetration testers and red teamers. Similarly, this Flare VM is specially made for malware analysts, okay? If you want, I'll give the link probably. Let me grab the link. No issues. GitHub Flare VM. You need to follow these steps to install the Flare VM. Flare VM is actually installed on Windows operating system, while Remnux is installed on Linux operating system. So you need a basic Windows 10 machine with the Defender Windows firewall disabled in order to install this Flare VM. That's the prerequisite. So you read through this, you will get to know what you need to do. So you need to follow, you need to have these requirements, you need to fulfill these requirements, and you can follow these installation instructions to install the VM. All right. Okay, I'll go to the VM now. I got the file. Let me unzip it. Update.zip. What? Skipping. I'll go to where it is, sample, update.zip, extract here, select, okay. I don't have application to extract it. Do I? Okay, so maybe I'll try to pull the sample once I extracted. Yeah, when I unzip it, I got a folder, and look at this. I got a file, CrowdStrike.exe. That's the binary. So it says CrowdStrike updater, but I don't think that's the case. We will confirm that in a moment. Let me go to this path like this, and here I see this, the file CrowdStrike.exe. So that's what I need to grab, and I start the Python server here, and let me grab it. CrowdStrike.exe. All right, I got the file, and you see CrowdStrike.exe. This is the file we are going to assess today. So this is the file distributed as a CrowdStrike fix for the CrowdStrike outage, but that was not the case. It is actually a malware. Let me enlarge this, and you see the logo here. It's a CrowdStrike logo. When I detonate this, it's gonna erase all the data in my present system, which is nothing but this Flare VM. It's a Windows-based VM, so it's a Windows malware. You see the .exe extension, so it's a Windows executable, so it's gonna destroy my operating system. I don't want to do that. First of all, we will try with the static analysis. Let me explain what is static analysis for those who don't know. Static analysis is nothing but it's one of the basic malware analysis techniques to assess the file, to assess the unknown or malicious file without detonating it, without executing the file. You just gonna open the file by using certain tools to understand or to predict the behavior of the file, right? That's the static analysis. So we are going to start with some static analysis, some basic static analysis, that too. So let me get through that. CrowdStrike.exe. That's the file we are accessing now. And you see the file is PE32 executable GUI Intel 80386. So it's a Windows executables. That's apparent. There is another utility called strings. So if we can use strings utility to read the human readable strings in this malware. Okay, let's do that. Strings CrowdStrike. So while we are analyzing the malware, we are going to look for the indicators of compromise, URLs, IP addresses, maybe domain names, or any folder names, any significant file names. So we are going to look for certain indicators like that. Okay, and apart from that, we are going to try and predict the behavior of the file. All right, let's see. Strings, and you see there are a bunch of strings here. Let me use the list utility to read through this step by step, and you see bunch of human readable text, but it is not understandable. It doesn't make any sense. And look at this. A search folder, autocomplete, get user default UI language, ADV API 32. So it is actually one of the libraries present in Windows API, I guess. So let me use my base machine to browse the stuffs about this. Not this. ADV API 32. It's a DLL file, as I said. You see, this is actually a Windows DLL. And if you want to know more about this DLL, we can just check out the Microsoft link. Cannot boot up Vista Home following the message. Okay, some community post. Maybe if I want to read more about this, it's gonna go and search in Microsoft site. I'm doing some Google dorking now just to get the guide of that. Answers, I'm seeing bunch of answers link, learn, server core functions by DLL, and you see the bunch of functions associated with every DLL in the Windows operating system. Here we can see ADV API 32.dll, and you see the functionalities of these libraries. You see, for example, access check. So what it could be? This function could be related to some access checking the access of a file or something else. We don't know. Maybe we need to learn more. All right. We are seeing some DLL names like this, and move file exw, get disk free space. So it's trying to enumerate the disk free space, kernel 32 DLL. So this is another DLL associated with some basic functionalities. Process next, process first, create tool help 32, kernel 32 DLL, get module base name, enum process modules, enumerate process. So it is enumerating the processes, psapi.dll. So there is another DLL here. I don't know what it is. Let's see. Let me open that. Do I have this psapi, yes, psapi dot, yeah, it's there. So it's a Windows DLL only, and you see the associated functions. So it's enumerating the process. The process enumeration is something related to this DLL. Okay, so if you want to learn the location of this DLL, you can simply go to system32 page directory of Windows, where you can witness all the DLLs. Delete file, look at this. So it's performing some file deletion. While looking the strings like this, you will get an idea, you'll get an insight what this tool is actually doing. Okay, it will give you some insights about that. Free library, load library. So it's trying to load some DLL file, maybe. close handle, set file time, compare file time, search path, bunch of sensitive functions, creating directory, sleep. And look at this, it is also using the sleep function, just maybe just to evade some dynamic analysis. um, get current process, exit process. Okay, bunch of functions associated with this. um, what else? Version.dll, OLE32.dll. Okay, these are all the DLLs associated with that. And look at this, some XML payload. There are some utilities to check whether the binary is signed or not. Maybe I'll check that. I forgot what utility it is. Maybe I'll check that in a moment. But now, for now, rest of the things are blobs. I don't understand any of these blobs. Okay, I'll just press Q and kill this. I don't know. I forgot the utility to use just to check whether the binary is signed or not. If anyone knows what is the binary name, you can post it in the chat section. Meanwhile, I'll try to Google. I guess I recently came across a blog post from OXTF where he was performing some incident response, some forensic analysis. There he used a utility to check whether the file is signed or not. Maybe let me grab that. OXDF's GitLab. Here actually he has posted a write-up for a forensic challenge, not a tracer for sure, not a corporate, it's a machine. Campfire, no. Noted, no. Constellation, maybe. Nubilium, no, not a Nubilium. Bumblebee, maybe. And Logjammer, maybe. Let's see. Ain Laden, maybe. Yeah. Or Subatomic. I think it's present in this. Let's see. Not this one. Bumblebee. Hi bro, Dharani Sanjay. I mean, the output of the string itself shows the presence of digital cert info. Yes, I think I've seen that. But the certificate is valid or not, that information we get from somewhere, right? Let's see. I can see some certificate info, and here you could see that. And you see some weird VLC media player text, which is totally irrelevant to this file. DigiCert. I see some certificate stamps, but whether it is a valid certificate or not, I need to validate that, right? Am I right, Sanjay? Correct me if I'm doing wrong. I'm just trying to check that utility. What utility is it is to check whether the file is signed or not. I've seen one of these blogs. I'm just trying to check which blog it is. Let's see. Not this one. Logjammer, I don't think so. The output of the string is actually having some certificate info, but I don't know whether the certificate is valid or not. Maybe right click the file and get properties and look for the cert info. That's a good idea. Let's see. I'm gonna go and open this Flare VM, and here I go to properties, digital signatures. It says name of the signer is VideoLAN. Is it using the VLC signing? Details. signtool.exe. Maybe I haven't used it. Let me check. Uh, it's hung. It's taking its time. I vividly remember I've seen one of these blocks, one of these OXDF blocks, blocks, where I found this. So you look at this. Here he is handling some exe file. I think this must be the stuff. Let's see. Executable log data, relationships, malware download. Okay. So he got a file and he extracted the file. Let's see. He's accessing the HTA file. PDF he is accessing. Okay, this one. Yeah, as Dharani mentioned, he is right clicking it and msoev.e signed by Microsoft. Okay. And yeah, this is what I was telling. The signature is okay. So I need to get a message like this. Correct. Let me check. Signature is not valid. Look at this. This is what I was telling. The signature stuff was there in that string output itself, but it was not valid. You see, it is given here. The signature is not valid. Digital signature of the object did not verify. Let me check another one. So it's taking its time. Yeah, it's not valid. The signature is invalid, but it used the signature of maybe the VLC media player, the certificate. It tried using it, I suppose. Yeah, so the certificate is invalid. It tried using the VLC certificate, but it is invalid still. Okay, that's fine. Now we got this string information and we found it is the certificate is not valid, and also we actually tried witnessing some we witnessed some functions associated with the DLLs that are imported by this binary. Maybe I'll go and check this binary in the Windows VM, the Flare VM. There I'll use it with PE tool, some PE analysis, portable executable analysis. I could use PE Studio, PE Bear. So I can use tools like that to assess this. Let's see. PE, do I have PE Studio? I do have PE Studio. Do I have PE Bear? I do have PE Bear as well. So I use PE Bear first. Yeah, this is the PE Bear utility. So this will, once you load your exe file into this will actually try to dissect the binary and it will show every section of the binary in detail. All right. So let's see. I load a PE file. The PE file is nothing but our executable file. So which is actually one of the types present in PE. Documents, malware, update, CrowdStrike.exe. All right, now we have loaded that. Let's see. So this is the DOS header and you see the binary, the structure of, the binary file, the raw binary file and its hexadecimal form. And here you see its disassembled form, its generic information, strings, DOS header, rich header, file header, optional header, section header, import section, export section, security, something related to some certificate signing. All right, let me go and check this DOS stub. Okay, NT header, signature, file signature, optional header. Okay, I can just click these options to see each sections. But before that, let me check this. I see multiple sections here: text, R data, data, N data, R source, RE location, some relocation stuff, I guess. So I see these sections, but I don't think this one is packed binary. So there is a technique called packaging a binary file just to evade the detection, right? I think this binary is not packed, because if it is packed, then we don't see this much of sections. So it is not a packed binary. Maybe I can confirm it with DEY or DIY. There is a utility. Let me check. I forgot. I don't remember that exactly. DIY or DEY something. DEY or DIY. I forgot the name. There is a good tool actually to check whether the binary is packed or not. It's there in this VM, but I need to grab that. DIY. Okay, before we check whether it's packed or not, let's get through this. Okay, now enough seeing that disassembly. Now see the general information. Here we see the malware hashes. So let me grab this hash and go to VirusTotal to check whether the binary is already detected or not. We know very well, we just took this binary from the internet, so we know it's detected. And you see there is a write-up about this new data wiper analysis. Maybe if I am not able to detect its behavior, if I struggle, maybe I'll refer this blog. But before that, you see it's found in various malware repositories. Now I'll open the VirusTotal and see it. How many vendors detecting it as malware? You see 58 vendors out of 75 detecting it as malware, and you see CrowdStrike updated.exe. That's the file name given, and the hash is same. The malwares always identified with this hash values, because that's a unique value for every file. So it's always reliable to identify a file with its hash. Okay, that's just an instruction, a guide. Okay, fine. Let me check this, and I see bunch of links related to this file. You see all this information came before 1 month. So this malware actually arose after the CrowdStrike incident. Look at this. So this is the file that we got. Let's see the relation. Looks like it is dropping some files and details. Okay, any interesting info? Certificate signing. So looks like it used the video LAN, the same sample, right? So we see the same signer info, but the certificate is still invalid. And you see the list of imports. We've seen all these OLEs, all these DLLs, OLE, COMCTL, all these DLLs associated with Windows operating system. I'm not positive about this OLE, but the remaining DLLs associated with Windows operating system. Fine, I'll close this. Now we knew this is actually a known binary. Let me go to that specific binary and see the strings. So we've already witnessed the string. It is doing some registry modifications also. Look at this. It's querying something, it's setting some registry value, it's creating a registry key, and it is deleting a value from the registry. So by looking at this function itself, we can predict what sort of behavior it possesses. Fine, I go to this rich header. Let's see, file header, it's executable. Okay, optional header, DLL characteristics. DLL can move image, NX compatible image doesn't. Okay. Section header. And look at this. When you see each section, you will see the privilege present in each section. When you see this .txt, this is the section where the code of the binary is present, and this .text section is often executable, and you see the permission here r-x, so it's readable and executable. So this is actually a default known privilege. The .text section is always having the executable privilege. All right. And I see some write privilege on data and end data, and the remaining stuffs are only having the read privilege. Okay. Imports, and you see the list of DLLs being imported. So when you click every DLL, you see the set of functions associated with the DLL, and all these functions used in this binary. And you see delete file. This is actually a function call. Delete file, so it's deleting some file. It's actually checking the free library, loading some library, some DLL side loading maybe. What else? It's doing some comparison, it's removing some directory, so it's definitely doing some suspicious stuff. Let's see the user32.dll. Set cursor. Let's see, I just try to enlarge this. Is window, so it's checking something. Get DLGLTEM. I'm not positive what it is, but let's see. So far we haven't see. It is accessing the clipboard also. Empty clipboard. It's opening the clipboard. It is setting the clipboard data. It is closing the clipboard. Looks like it is setting some clipboard stuff. What is this GDI? Deleting an object. Okay. Fine. Shell 32. Browser for folder, get path from ID list, get file info, shell execute. All right. ADV API 32. And look at this. This specific library is performing bunch of registry operations. So it is deleting, it is writing, it is reading the registry values and the registry keys. All right. COMCTL32. Image list add mask, image list destroy. What? Let's see what it is. CMCTL32.dll. COMCTL32.dll. Okay, let's see. COMCTL32.dll. Site Microsoft. What is the difference between PE Bear and Ghidra? PE Bear is actually a PE file analyzer. It is actually a static analysis tool. So, but Ghidra is totally different. It is actually a disassembler. Ghidra is actually a disassembler. When you load a binary into Ghidra, it is going to try to decompile your binary, and it's going to present the assembly language, the assembly code of that specific binary, and also it try to decompile. There is a decompile engine in Ghidra. It's going to decompile your binary. Though the decompiled code is not the original source code, it's just trying to get the closer, the code that looks closer to that source code. So that's the thing. So Ghidra is actually a disassembler. It's actually used in the advanced static analysis, but the PE Bear is actually a basic static analysis tool. So whatever we are doing right now is just a basic analysis. We are just trying to predict or try to guess what is the behavior of this file by seeing its functions, right? Since it is an exe file, it is importing bunch of DLLs. If it is a DLL file, we would see it exporting some functions to other binaries. Let's see what is this COMCTL. COMCTL32. Look at this. So it's actually a Windows DLL. The list of functions associated to that. DPH destroy means what? I want to learn that because I see here image list destroy. Can I see that as well here? Let's see. Image list destroy. Do I have that as well? Yeah, I do have that. Where it is? Yeah, here it is. Let's see what it does. Is it deleting the the virtual shadow copy, the VSC, I guess, in Windows to store the operating system to the previous state? Function, yeah, function. Let's see what it is. Here it is. Image list destroy. What it does? Let's learn. Handle to the image list to destroy. What it does? What are the arguments to this? High image list, high YAML. Destroys an image list. And look at this. This specific function is destroying some image list. So it might be used to destroy the virtual shadow copies. Let's see. Shadow copy. What is the full name? Volume shadow copy. I'm sorry, I was pronouncing it wrong. Volume shadow copy. Yeah, the volume shadow copy is actually a snapshot of the disk of the Windows operating system, I suppose. And I think I can show that a great example. There will be, for example, if I just choose any of these file, maybe I go to the VM. Here, if I go to documents, or just I keep my cursor over a file and go to properties, security, details, or previous versions. Yeah, here you see the previous versions. So you'll be able to store the file to the specific point if it is taken as if the snapshot is taken in that specific point. So that's called the volume shadow copy. The malwares mostly the wipers try to delete this volume shadow copies also when they are wiping the whole stuff. So it actually prevents the victim from restoring the data. Metadata of particular file. Okay. All right. But okay, fine. I agree. Dharani says the function is related to deleting or removing metadata of a particular file. Image list means, what do you mean, Dharani? Is it related to that volume shadow copy or something else? Okay, let's see. Image list, create image list, add mask. Okay, OLE32, what we have here. Task memfree, initialize OLE. Okay, let me see whether this OLE is present in the Windows DLL list. OLE 32. Yeah, it's there. And look at this. OLE means object linking and embedding. That's the definition for OLE. And it has bunch of functions here, and some of these functions used by this malware. Fine. Version.dll. Get file version info size, get file version info W, where query value W. Okay. So as far as I know, anything that is embedded on RSRC section, resource section. Yeah, I came across resource section often came up with some files embedded in it. I'll use PE Studio to open this binary. In PE Studio, if I check this resource section, I will see if any file is embedded in that section. I could see that file in that. Maybe I'll open it with that. I think I check this resource section. I see some files here. Is it a file? In resource section only we see the icons and all. For example, if you see this CrowdStrike binary, you see this CrowdStrike icon. This icon is usually embedded in this resource section. That's the purpose of this resource section. And I think this is the icon file. So yeah, that function is something related to that. Number of named entries, major versions, character, timestamp, content, and you see the content here. So it has only one file, I guess. You see the content, and this is the icon of the binary, and which is added in this resource section. Security, that's actually the signature info. All right, I'll close this, and let me open it with PE Studio. So I'm just doing the second stage of analysis, opening it with PE Studio. Let's check this. In resource section, I'm having bunch of stuffs. Version, okay, manifest, icon group, dialog, icon. Here is one more icon name. Okay, what is this certificate? And it says it's invalid. Look, PE Studio is detecting the name is VideoLAN, some VLC certificate, VLC media player certificate, but the signature is invalid. Okay, signature is null soft. Okay, so these are all the stuffs highlighted in red. DOS header, I can simply enlarge this, maybe. No, I'm not able to enlarge this. Directories, import resource, security, relocation, import address table. Okay, so these are the resource sections. Team, chat, any idea what is the tool to use to detect whether the binary is packed or not? Any idea? What is this null soft? I've heard this somewhere. Let's see. Sorry. Null soft NSIS. Yeah, NSIS. What it is? NullSoft is actually a professional open source system to create Windows installers. Open source tool that enables developers to create efficient and customizable Windows installers. Okay. Okay. So this might be the tool used to create the installer. So it pretends to be the CrowdStrike update. So I think this NullSoft is played a role while building this binary, I guess. And look at this CrowdStrike update. Okay, certificate strings. So it took its time. So it's gradually loading. Now we can see many titles highlighted. Section R data, access token manipulation. I think this PE Studio also try to highlight the dangerous functions involved in this. Adjust token privileges, lookup privilege value, open process token, registry delete key, write private profile string, querying the registry stuff. So which is always, and look at this, the technique. It is also mapping it with the mitrate technique, data destruction, and you see reg delete value, reg delete key. So it's deleting some registry stuff. So obviously some data destruction is involved. And these are all the functions related to process injection. Find Windows X, send message, send Windows long, send message timeout, get Windows long. I'm not sure. I had to learn the Windows API and its functions. Maybe I'm just trying to understand what it does just by seeing its name. Lookup privilege value. What are all the stuff highlighted in red? Look at this input capture. Get async key state. Some key capturing, maybe. Some deleting, data deletion. Delete file. So it is deleting some file. Finding the first file, next file. writing a file. And look at this. So it's writing the file. So as they mentioned in their blog, it is actually trying to overwrite the existing files with some null bytes. Maybe when we go to the dynamic analysis, we will understand that behavior extensively. Some file moving, some file movement, some file copy operation, remote file copy, move file X, process discovery, get current process. So it's getting the current process. So it's injecting the process, I suppose. Execution through API. So it's creating a process, shell execute. And look at this bunch of malicious functions involved. Okay, I'll scroll down. Clipboard operation. So we already noticed it. Scroll down, set current directory, system parameter info. Else. Any other interesting stuff? I see bunch of stuffs, but only 43 events flagged here. I can just, I can simply organize that. Here you see all the list of potentially malicious behavior. By seeing this migrate technique, you can understand or you can just predict what it tried to do. Maybe. I don't think any network connectivity. I don't think it establishes any network connectivity. Look at this. If any function involved, if any function is related to the network, establishing network connection, let me know. But I don't think there is any network related function is involved here. All right, I go to resources section, same imports. Yeah, here it flogged 31 functions. Sleep function, sandbox evasion, and you see the sleep function is potentially, I mean, it's usually used to evade the sandbox, particularly the dynamic analysis. So it sleeps for a while, then it starts acting on the system that it is running. Let's see, execution through API, process injection. Oh, bunch of weird stuff. Look at this. Data destruction. Okay, I think we've done that. Let's move on to the next one. Characteristics of each section. What is the entropy value? I think the entropy is greater than 7, then it is packed binary. I think that's the case. If it has to be more than 7, the entropy value. Since it is not more than 7, I don't think it is a packed binary because we were able to see all the libraries, all the functions involved in this. So it's not packed binary, definitely. I need not to check that anymore. Indicators, let's see what it is. Signature, digital signature is not valid, so it's obviously an indicator. And you see bunch of migrate techniques mapped with the behavior of this. Overlay, nothing. Okay, I think we've assessed this binary with this tool. Now let me go to this stuff. Do I have flaws? I do have flaws. So flaws is actually another tool that can be used to grab the behavior of the binary. Flaws, it is another static analysis tool. So I'm just executing that. Flaws space the binary name. So it's analyzing the program. It's gonna fetch the behavior of the binary in a moment. Let's wait. So far we are just doing the static analysis. That's all. That to the basic static analysis. Maybe we can open tools like Ghidra and open this binary, and we can check what it does by seeing its assembly. We can try to get some idea with that. Let's see. Look at this. I think we got the output. It gives bunch of data to us. Let's see. Gosh, it opened the whole string. I never wanted this. I want to see. It will just put the data section wise. I want to see that. Let's see. Do I have flaws here? I do have flaws. Okay, I'll try here. Flaws. CrowdStrike. Like this. If the outcome is huge, I'll try to store this outcome in some file, and I read through the file. Bunch of outcome. Same way like we got before. I think I need to store it somewhere in a file. Let me redirect it to flaws.out, maybe like this. So once it is done, it will forward the outputs to the file. I can open the file later and read through that. Let's see. So far we are just seeing the tip of the iceberg. We need to do a lot of stuffs henceforth. We need to do some assembly analysis. Then we need to go to the dynamic analysis, and there is another section called advanced dynamic analysis where we can use debugger to execute the binary in a controlled way. Right, now we have the results now. Do I have the file here? Yeah, it's written. I go and open it with Notepad++. Let's see. Open downloads, malware, update, flaws.out. So it's a packet capture. What? No. Okay, fine. Look at this. This is what I wanted. What it says, flaws results. Identified language is unknown. It just wrote the string values. How I could get the whole behavior of this binary. Is there any? Sorry. Let's see. Flaws help menu. Let's see. So it is also supporting the binaries that are written in Go and Rust. Okay, good information to know. Positional argument, sample, minimum length, static. Okay, debug quite. Do not extract static strings. Can I use this flag? Maybe like this. Flaws. I paste this, and here I give CrowdStrike.exe. Let's see. I don't want to see the strings anymore. I want to see the behavior that assessed by flaws. Tight strings. Look at this. Do you have anything? Stack strings 0, flaws, tight strings 0, decoded strings 0. Okay. So it is not finding the other results apart from the strings, apart from simply displaying the strings. That's what I can understand from these results. The flaws extracts the following string types. Okay, so we only got the static strings, not these remaining strings. Okay, fine. What else? What we could do then? What we could do now? Maybe let's go and use Ghidra. Do I have IDA here? IDA freeware? Yeah, I do have. That's awesome. I agree. Okay, let me disassemble this. Now I am disassembling. I am jumping into advanced static analysis. So let me go to this update CrowdStrike.exe. I'm loading it. So this is also a static analysis. I'm not going to detonate this binary. Instead, I'm going to open it with the disassembler and see its assembly code. Can't find translation to virtual address. Continue. Yes. Okay. We got that, and here in view somewhere there is an option to enable the comments. Let's see. Not a quick view. Calculator, unhide, search, or options maybe. Options, general, here auto comments. This one. Fine. All right. Do I have a main function here? There is a function called start. Is it starting here? I'm not positive. Okay, let's see what is the protections against this binary. There is a file called utility called checksec. Yeah, checksec. That is the utility to check whether any security measures taken against this binary. I think it is not installed. It is not having the internet, so I cannot use that right now. Maybe check the import table. Let's see. Now I'm seeing the graph view. I can scroll down through this till the end. So what it does. Okay. What I click start. So when I click start, it is starting here. So looks like this is where the program begins. I'm not sure. Maybe if anyone know how to start or where to start when doing this static disassembly, maybe you can let me know. This is the first time I'm analyzing malware in a disassembler. So I'd like to get your inputs, if any. Okay, I'll just check this, what we have. Some prologue, I guess. So this one is a prologue. Sorry, this one is a prologue. This one is an epilogue. So before calling the function, it is doing that, but it is pushing some value into the stack. So this is the push instruction. So pushing something into the stack. I mean, if you don't know what I'm just speaking, you can refer my previous reverse engineering video. There I tried reversing a couple of simple exe files. Error while writing temporary file, make sure. Okay, I think I need to go to the top again. And here, error writing the file, writing temporary file. So it's trying to write some file. Is it? Let's see. Make sure your temp. Yes. Okay. I don't understand what it is. Let's move on. Indirect call near procedure. Let's see. Scroll down. Gosh, the graph view has disappeared. We have the graph view now. Graphs, flow chart. Oh gosh, it's gone. If I click spacebar, it has to show me the graph view, but I'm not seeing it. Graphs, flow view is not available now. What the heck? Do I need to load it again? I don't know how to bring that graph view back. Excuse me, I load this again. Data freeware, open it. The previous, no, I want to load it as a new binary. Let's see. Overwrite. Yeah. Yeah, now I see the graph view again. I go to start. Here is the graph view. Scroll down. Let's see what we have. Initial error mode OLE initialize. Get file info W. So it's calling this function, and after that it is pushing some error, NSIS error. Okay, get command line W. Let's see what it does. Command line W function retrieves the command line strings for the current process. Okay. So look at this. This function is called here. Get command line command line W, and later if you see the stack, one string called LP string 2 is pushed into EAX register, and then this LP string 1 is pushed to EDI, destination index register. Okay, then it is pushing LP module name, or it is pushing the base pointer. Okay, now get module handle W. Let's see what it is. I'm gonna go and check this as well. Maybe like this. Retrieves module handle for specified module. The module must have been loaded by the calling process to avoid the race condition described in the remarks section. Okay. Go to this assembler, and here once this condition, and you see this before it actually ends this specific box, it is actually trying to compare this stuff. And look at this, there is a compare operation, and it's trying to move to the specific location if not 0, I guess. Jump not 0, not equal to 0. I think that's what. It is moving to this one, and here it is calling char new W. Okay, I don't know what it does. Literally, I don't know what it does. But when I uh, proceed. When I check further, what I could understand here, do I have any interesting stuff? A lot of things happening. Get temp path W, what it does. Let's see. Retrieve the path of the directory designated for temporary files. Okay. Get Windows directory W. Look at this. It is getting the temp directory. So probably it is dropping something to the temp directory. Maybe it could be something. It could be dropping something to the temp directory. If it is not clear, maybe I'll try to enlarge the font. Now it is fine, I guess. Let me scroll sideways. And you see the string here, where it is, where the heck it is. I've seen the temp somewhere here. Word temp. Here it is. Get Windows directory W. Offset string 2. So it has the value of temp. So looks like it is trying to grab the temp directory. Get directory W. Let me check what it does. I'm gonna go and paste this here like this. Sysinfo API, it belongs to .h. So that's the C library. Let's see. The function is provided primarily for compatibility with legacy applications. New applications could store code in the program files folder, persistent data and application folder. Okay. Retrieves the path of the Windows directory. Okay. So it gets the path of the Windows directory. So we try to get the temp path. What sort of operation is done on that? Delete file W. Okay, once it done, it succeeds, it move to this specific function, OLE uninitialize. What it does, let's see. Initializes COM library of the current apartment. It identifies the concurrency model as a single thread apartment, enables additional functionality described in remarks section. Applications must initialize COM library before they call the COM library functions. Memory allocation functions. Okay. Something related to COM library. I'm not sure what it is, but I've heard it, but I cannot explain it right now because I'm not confident to explain that. Why I came to this one, because you see, I'm just following this green arrow that I keep my cursor on that. When I scroll up, you see when the specific block, it is actually testing these two. It tests the EAX register with the same register. I think the test operation is something related to the comparison or some subtraction operation, I suppose. So we try to compare this both of these registers, or the value present in these registers. If both are same, it is jumping to this location. So that's what it does. Let's see. That's why I followed that. And it is actually dropping some file to temp directory. Then it moves to this OLE uninitialize. Okay, it's calling some COM objects. I'm just guessing. Correct me if I'm wrong. Okay. Then when it succeeds, it is going to this specific block. Here also it is doing some comparison. It succeeds. It is coming all the way to this box where it is actually doing some again once again a comparison. Then it moves to this one and it is ending the process. It exits the process. But here, when the OLE uninitializes fail, it is coming, just following this red line, it is again coming to that exit block of the code. Okay, now what is happening with this green line? And here it compares something. I don't know what is the value currently present in this EBB. Maybe while we are debugging, we can pause this execution anywhere you want, and you can see, you can read the values present in the every stack. The values present in a stack, values present on every register. But since we are not doing debugging, I'm just trying to guess its behavior. Okay, OLE, first of all, it is accessing the temp directory. It may be dropping some file in the temp directory. I'm not positive. Let's see. Then it moves to these blocks. Okay. It is actually getting the information about the current process. Get current process. Let's see. I think that's the thing. Let's see. Go here, scrolling all the way down to this. So it is dropping some file to temp, and OLE uninitialize. It is getting the current process name or the process detail, I guess, with this function. Let's see. Retrieves pseudo handle for the current process. Okay, so it looks like it's retrieving the handle, the process handle. Return values pseudo process pseudo handle the handle. Okay, I go here for this, and look at this. It is setting a privilege. It is setting up a privilege here. SE shutdown privilege. Okay, let's see what it does. SE shutdown privilege. Do I have this here? Let's see. SE shutdown privilege required to shut down a local system. Okay, so it is shutting down the local system. Why? Exit Windows X. Exiting the process. So looks like it tried to shut the system once it done the file destroy. Once it destroyed the files on the system. I could see bunch of stuffs here. Close handle, and look at this. It is actually deleting the files. Let's see. Setting current directory. Sorry, create a directory. Set current directory, and okay. I can see one file name called nsu.tmp. Okay. What else we have? Okay. Error while writing a temporary file. Fine. Though I couldn't explain all these stuffs present in this disassembled code, I actually tried predicting its behavior. Looks like it is accessing the temp directory, dropping some files into the temp directory. it is setting up a current directory, it is performing some delete operation, and it is shutting down the system. So these are all the operations that we predicted by seeing this disassembled function, the disassembled code. Maybe it's time to move to the dynamic analysis. Okay, let's see. I go here. Maybe before I detonate this sample, what are all the tools I need to open? Do I have sysinternals tools here? I need a fake net first of all. So here I have a fake net, but do I have remnex? So in remnex, I think I have a tool to feed the network traffic. If it initiates any network traffic, then I should be able to respond to those traffics. For that, I think there is a utility, a great utility. I forgot the name here. Let's see. Do I have that utility name here somewhere? Not this one. Okay, I don't have it here, but I think I must be having that utility. Let's see what it is. I think it's called, it ends with sim, I guess. inet sim. Do I have inet sim? I do have. And look at this. I just started the inet sim here. Now it is actually listening on various ports, and you see here it is serving on port 443, port 80, port POP3. If it is initiating any SMTP traffic, then I'm listening on that as well. If it is posting some data to some FTP server, then we have an option to capture that. Look at this. It is actually starting bunch of services. That's awesome. inet sim main process started. Okay, I'll kill this first of all. I go for the help menu and check its extensive functions. Maybe H like this. No, it's not a valid IP address. Let's see. Do I have a manual page for this? Man page for this? Yeah, I do have. inet sim is a suite for simulating common internet services. Yeah. Config file. So here is the config file where we can see the list of, okay, the bind IP address, the IP address to bind service to. Okay. Can I fake time, fake init data, fake auto recreate, fake PID file? Okay, inet sim session like this. So you need to use command like this to start this, right? Okay. Let me check the config file first of all. Cat inetc.conf. So this one. Okay, I see bunch of stuffs here. Okay, fine. I can initiate the fake net now. Maybe what is the DNS configured here? EF config like this, or IP config, sorry. IP config. I don't see a gateway here. And also the DNS 10.10 15.1. So I don't want that to be my DNS. I'll configure my gateway and also the DNS service as my Remnex machine. So let me do that modification now. I'm gonna go to this network and internet settings. What is the IP of Remnex? I keep forgetting. IF config 10.10 15.11. Let's see. Properties. 10, 10, 15, 11, 255, sorry, 255, 255, 255, 0. I think that's the network range, right? Can I see Remnux? Yeah, 255, 255, 255, 0. And it must be 10, 10, 15.10. So that's the IP address of my Remnux machine. Sorry, 10, 10, 15, 11. So this one is 10. I could see that if config, sorry, IP config. So currently it is 10. So IP is 10, but the gateway should be 11, and also the DNS server should be 11. 10, 10, 15, 11, like this. Okay. Now I configured the Remnux machine as my gateway. Looks okay. Now any traffic goes out of this machine, it will just go to the Remnux machine. No. I just verify it with the IP config command /all. Now I configured that as I expected. Okay, fine. I'm able to ping my Remnux machine 10, 10, 15.11. Awesome. Fine. I go here to Remnux. Here I'm going to initiate the Wireshark and also the inet sim. Okay, let's see. if config, sorry, like this. ENS33, that's the interface. I see bunch of MDNS. I don't want that. I don't want to see that. Since it is a Windows machine, it is sending some broadcast messages. So this MDNS is something related to finding the IP address, I guess. Finding the IP address of some unknown machine. Yeah, that's what it does. Okay, I'll leave it, but I'll simply enable a filter by mentioning the name of the machine, the Windows machine, 10, 10, 15, 10, I guess, like this. Yeah, 10, 10, 15, 10. Okay. Now it's fine. Wireshark is running. inet sim. I start this. I need to bind this to the ENS33. So let's see how to do that. Bind address and the IP address I need to mention. Okay, I'll do that. Q, like this. Okay. inet sim hyphen bind address, and I need to mention the IP address of the Remnux machine. Config, like this. 10, 10, 15, 11. Okay. 10, 10, 15, 11. Now it's fine. It's listening on 10, 10, 15, 11. You can confirm it with SS-LUNTP. Now you see bunch of stuffs listening on that port. All right, that's awesome. I'm gonna go and okay, it's listening. It's ready. Now I go to Flare VM. Here I go to sysinternals. Do I have sysinternals utility? Where it is? I need to get that sysinternals. Maybe on tools. I see utilities. Okay, I think I must have used kappa to analyze the capability of the binary. So let me do that quickly. I go to this place. I have CrowdStrike binary, and here I use kappa, so it will bring the capability of the binary. Instead of floss is actually a tool to check the strings, but I was using a wrong tool. I should have used kappa. This appears to be an installer. Kappa cannot handle installers well. This means the result may be misleading or incomplete. You should try to understand the install mechanism and analyze created files with kappa. So it detected it as an installer. We already see it is actually a nullsoft installer, NSIS. So it's built with that. So it's actually an installer. So when I click this, it will just open the installation manual. Let's see. So once I install it, then only it will load some file into the temp directory. I guess from there the detonation begins. Okay, that's fine. I go to tools once again. Where it is? Tools, packers. Okay, not this one. UPE, bunch of files to explore the PE files. Bunch of tools. Reconnaissance, EAD Explorer, registry. Okay, RecShot. Okay, I've heard this RecShot. So I need to take the screenshot of the registry, snapshot of the registry before I execute the sample. And once I executed the sample, I can use RecShot once again, and I can take the snapshot. So I can compare both the snapshot. If any modification done on the registry keys, then it will clearly say what are all the modifications happened. But we will execute that. Okay, I'll execute it now itself. RecShot. HTML document or plain text. So this is the first shot before detonation, like this. Output path, maybe I'll store it in the path that I'm using right now. Documents. I go to documents, malware, update, like this. Here I can put it. Okay, I'll take the first shot and save. Now it is taking this snapshot of that registry. Can I enlarge it? Hope you can see it, right? And look at this. It has taken it took bunch of keys and values, and the first shot is taken now. So I'm going to keep it open. Let me go to this path and check whether we got any file. I don't see any file right now, but it's happening. It's taking the snapshot of the registry. Yeah, look at this. And here is the Hive file. I go to documents, malware, update. Here I say before detonation, like this. Okay. I'm saving it here. Okay, I saved it. Now I can simply click the second shot and take this second shot, but after the detonation. Okay, that's the thing. Fine, I'll just keep it open. And what next? So once I took the second shot, I can compare it here itself. Fine. Now we have a way to capture the registry changes. I found the malware is doing some registry changes, so it is useful definitely. Let's see what else I can use. I'm just exploring the list of tools that I can utilize. Let's see. Debuggers, disassemblers, documents. Okay, PDF parser, easy viewer, .NET, some DE for ILSpy, DNSpy to analyze some .NET malwares. So DIE is the file. That is the utility to check whether the binary is packed or not. I think I can use this one also once to check in which program this binary is written. Let's see. I'm gonna go and check this PowerShell. Here I use the tool die to check against this binary. And look at this. The language is C and C++. So this binary is written in Microsoft Visual. It compiled with Microsoft Visual Studio, C and C++ compiler, and you see the language. It's Visual Studio 2010. The installer, Nullsoft Scriptable Install System, and it's a binary linker, Microsoft linker operating system. Yeah, so this is the stuff that I wanted to check. What is this? What if I check the advanced? Give the string, signature, entropy, overlay. Yeah, bunch of stuffs to analyze this file. Import table. So it pulls the import table, entropy. Yeah, look at this. The entropy stats. What else? Virus total. No, I don't have internet connectivity. Memory map. Okay. This is Yara. I think we can use some Yara rules here, and we can detect whether the malware is possessing a specific behavior that we written in our Yara. Resources. When I see resources, okay. Anything, any other stuff? Extractor. Visualization. What is this visualization? Okay. Disassembly view. All right. Now we found it's written in C and C++. Okay. I'll close this. Maybe I'll try to check the other tools that might be used in dynamic analysis. File, hash my file, Magica, bindiff, forensics.exe, Inno, setup, Java, Android. Okay, some Android analysis tools. Okay, memory analysis tools, networking tools, FakeNet, Packers. Okay, some packaging tools, PE analysis tools, productivity tools. Okay, reconnaissance, EAD Explorer, registry tool, shellcode. Look at this. Some shellcode analysis tools, I guess. Utilities, API monitor, Kappa, CyberChef, Procmon, or Process Explorer. We can use Procmon, Process Explorer. I actually used Proc.dot in one of my previous videos. It's been actually I have done that video before 2-3 years, I guess. Using Proc.dot. It is actually an amazing tool. But before that, you see the sysinternals utility. I can use any of the sysinternals before I start this. I go to Remnex and see, do I have any other traffic here? Let's see. I got bunch of traffic here, and look at this, some DNS request. Okay, I think I should stop this and reinitialize before starting the detonation. Okay, let's see. I go to I see bunch of tools here. Desktop, tools, utilities, Proc.dot. So I'll start this. It's been a while since I used this Proc.dot. Let's see. Monitoring logs, Procmon and Windom. I think I need to feed these two files just to get that graphical view. Okay, I think that's what it is. So I should obviously start Procmon and Windom. I don't know what is Windom. What is the outcome? Which tool will give me the Windom stuff. Let's see. Win dump. Win dump is detection useful for internal transfers. Support of TCP dump of Windows. I think the network logs. Okay. Let's see. Okay. I start Procmon. Also the process explorer. Now I start the process explorer. I only want to monitor a specific process. So how I could do that? Maybe I go to monitor and filter process like this, maybe, or there is an option. It's been so long since I used this utility. That's why I'm struggling. Find users, or can I just filter it somewhere here? Let's see. Create dump, create mini dump, create full dump. So it creates a process dump, I guess. Filter processes, Control F. So let me do that. Control F, but I don't know what to filter. Okay, users help. Okay, fine. I open the Procmon now. Here I see the list of registry activity, file system activity, network activity, process and thread activity, and also the profiling events. I'll choose this as well, and here I can filter the events, I guess. Yeah, look at this. This one, maybe not a process name, maybe the file name I can filter it with. Let's see. Detail, integrity, image path, path, result, session, user. Okay, let's see the process name. So when I detonate, I think it will create the process name as CrowdStrike.exe. So why don't we try and choose that as a parameter? Process name, contains, excludes. Okay, maybe I'll put like this, contains. CrowdStrike.exe, like this. And also I'll add one more filter. Okay, let me process name contains this CrowdStrike.exe. So I want to see those events alone. I don't want to see the remaining events. I'll close it. Now I checked only this one, CrowdStrike.exe. Okay, I apply. Now I'm listening. I'm listening on the process monitor as well. I keep it minimized. What else? Process explorer. Let's see. Process explorer. Do I have WinDump here? Windows object. Okay, I go to the process explorer somewhere. Okay, here. I open this. Here, even though I try to filter the specific process, let me check like this. Process or filter process. Okay, I'll just keep it open like this. Before I detonate, I took the shot, I took the registry shot, and I keep the process monitor open, and I keep the process explorer open, and proc dot. Once I got the procmon dump, I need to put that, and win dump. Let me check that. Do I have win dump here? Looks like I do have win dump. Listening on device npf some unique ID, UUID. Okay. 0 packets captured, 0 packets received on filter. Okay, win dump hyphen hyphen help. What about that? Let's see. Or hyphen h like this. E file interface. Okay, I need to listen on the interface, a specific interface. Okay, I enable this as well. Let me open a tab. Here I go to win dump and on which file I need to get that outcome. File count, file, or file. Result, I think result to be stored into a file, I guess. Or double read file, write file. Okay, I think this is something related to reading and writing the file. Yum secret interface file. Okay, let me Google it before I start this, because it will take just few seconds to do the dynamic analysis. But before we start the analysis, we need to make sure we just started every tool and we are running it. Okay, win dump command to store capture in a file, maybe like this. Win dump manual, understanding TCP dump and win dump. So it is actually the TCP dump version for Windows. Let's see, TCP dump -d. So they gave it for TCP dump. What about win dump? Do I have it here? But here, C file size. Okay, print each packet in ASCII. Exits after receiving, count the packet, writing the raw packets to save file. Okay, before writing a raw packet to save file, check whether the file currently have larger file size or so. Dump the compiled packet matching. Okay, what about writing the file? Use file as an input for filter expression. No, I don't need to input any file. But what about writing a file? Write raw packets to a file rather than parsing and printing them out. Let it be printed out with R option. What about R option? Raw packets from read packets from file. Okay. All right. I'll use -w to ipconfig win dump -i like this, and Ethernet 0. So this is the interface, and -w writing to a file. Maybe I'll name it as capture.pcap, maybe like this. Let me do that. Or like this. No, otherwise I'll just start this. 10 10 15 10 like this. No, invalid adapter index. When I open the Wireshark, what I'm getting? Ethernet 0. Okay, I'll remove this. I simply write file pcap like this. Okay, now it started. Now it is listening on. Let's see what we can do now. See documents, here malware, here update. Okay, now I have all these details. Capturing it. Hive file, I have taken this snapshot of the Hive, and process monitor is listening for the events. Now all ready, I think all set. I can go and start the stuff. Let's see. This is the first time I'm detonating a Viper, so I need to make sure I'm not infecting my main machine. So let's see. Settings is actually sandbox options. Okay. Fine. Let's see. Okay. Fine. I'll go and start this, but before that I'll restart this, continue without saving. Okay. Yeah. Okay, now I'm listening on the internet interface. Okay, now I go and detonate the malware. Now listen carefully. I'm detonating the malware. Hope everything will go well, and I'll be able to capture the event that I want. Probably. Let's see. Okay. I go and detonate this. I double clicked it and I detonated. So it's asking, it is giving me the UAC banner. Do you allow this program to make the change? Since it is installer, it is asking that. Yes, I want it to make the change. And let's see what we have. And look at this process monitor. And you see the process name. It's CrowdStrike.exe. And it does bunch of stuff at the back end. This is what I was expecting to see. Are you sure you're about to start the CrowdStrike update? It is giving me the warning page, and I give yes, and let's see what happens. The update has been applied and will start soon. I said okay. And you see the events, it keep rising. Wow. I see bunch of registry events. And look at this. It creates some file on this syswow64. And how about the temp directory? Do I have a file in say temp directory? Let's see. User, where is that? Where is the temp directory? Maybe I go and show this file system event. Here, okay, let me see that file system event as well. Okay, so it's creating some file, some DLL file. ntdll.dll, kernel32.dll, kernelbase.dll, sysmain.dll. Look at this. What? Let's see the process event. I close the registry event. File system activity also I close. Network activity I keep it open. Let's see. Process and thread activity. Yeah, I think I need to see that alone. Okay, let's see this. It's actually starting the process. It's creating a thread, loading the image CrowdStrike.exe, and it is calling all these DLLs here. Then it is creating a thread. Thread ID is 1428. Okay. Then later it is loading some images from this path. Now it is creating some files in this syswow64 Windows directory. Let's go and see that. Windows directory syswow64, and look at this. It's creating bunch of files here. It's loading bunch of images, DLL files. Wow. Let's see. It's creating a thread. It's creating a process. Look at this. It's creating the CMD process. And let's see what is the command is executed. See this? It is executing this command cmd.exe /k copy carol space carol.cmd and ampersanding carol.cmd and exits that. Okay. Now it's executing some command. It's apparent. Let's see. What is this? Stack include process create highlight stored process name. Okay. I go and check the properties and look at this command. The command is getting executed. Wow. And this is the command it's getting executed. Carol.cmd. I don't know what is the file, but I'm just keeping it here. Maybe I'll create a new file and put it here. So it is executing this carol.cmd. Fine. I go here, check further. What happens here? CrowdStrike.exe. It's creating a thread. And look at this. It's creating a process for that. The previous event was also it was loading the image here with this. Sorry. It's creating the process. So this command is getting executed. I don't know what that file is. Let's see. From where I can fetch the file. Carol. I need that file. Carol.cmd. Where it is. Do I see the file here? File system activity. I go and check that. I disable this process activity, and here in the file system activity, I go and see the Carol. Can I see any file like that? mtdll sysmain. Okay, some comctl dll. Apart from these DLLs, do I see any other file names? Come on. There are a lot of files. I see some DB files. Okay. Okay, go to the rec shot and take the registry here. Registry shot. I'm taking the second shot now. I should have given this shot and save option. What happens? Let's see. See, some malfunction. It is behaving weirdly. Since it is a Viper, it is trying to remove some important files. Great. Let's see. Where is that CrowdStrike? CrowdStrike.exe. It is doing all the damage. Where it is? Do I see that? CrowdStrike.exe. But what about the network log? Do I have any network log here? I go to Remnux, SSDP, DNS. What about this? I need to see the traffic between the traffic between the protocol hierarchy, maybe like this. DNS, some DNS queries. So let's see what are all those DNS. The machine 10, the IP 10, it is querying some DNS. Let's see. Query what it is. It's querying some name, some weird DNS name. And look at this. It's querying icanhazib.com, api.telegram.org. You remember we've seen it is reporting something to Telegram, and that's what we are seeing it right now. Maybe it is trying to hide it over DNS. And look at this. It is storing the capture in these files. That's awesome. I go and check this. Telegram, follow UDP stream, and look at this. It is trying to resolve the URL api.telegram.org. So it's using Telegram as its C2, I suppose. So what sort of status it is trying to uh, it's trying to send? Uh, I wonder what it could be. Let's see. I remove this filter. Let's see what are all the other. I filter only the DNS request because I see only DNS here, and I see icanhasip.com. Let's see what is the domain. Follow UDP stream, and you see icanhasip.com. So this is another indicator of compromise. I remove this and go to, sorry, I put the DNS filter, and here if I check this, it is posting something to api.telegram.org. That's clear. Let's see. What is this? ICMP. What? I can see the protocol as DNS, but here it says the protocol ICMP. Destination unreachable, the port unreachable. Follow UDP stream. Okay. But I could see bunch of queries sent by this 10, 10, 15, 10 IP to various URLs. API dot where is that? API MS, and these are all the normal traffic, I guess. But icanhasip.com. Let's see. Let's query what is that URL. Maybe I go to VirusTotal to see its reputation. VirusTotal icanhasip.com. Let's see. icanhasip.com, like this. It says suspicious. Okay. api.telegram.org. That's actually a Telegram API. api.telegram.org, like this. Telegram bot API. So it's posting something to Telegram. So we can clearly say it's posting some data to Telegram over DNS. That's the highlight of this. It is using the DNS traffic to post something on something to C2. So that's what I can see here. That's clear. That's apparent. Fine. I go to next stream. Same stuff. icanhasip. If I follow the UDP stream, I get nothing apart from the URL. Okay. I filter DNS. Do I see any other protocol apart from this? Some ERP. I think that's it. It's using SMB also. Server message block. Let's see what is that. SMB, like this. All right. So it's using DNS to post something on the stuff. And look at this. I took the red shot and I'm comparing it. Compare an output. Okay. Let's see. And look at this. It's creating a file in this directory. I'll go and check that. Let's see. I go to this C users directory, where it is system, system Windows directory, syswav 64. So this is the directory. Date modified. Today date is September 1st, but I could see some file msr.exe. Is it created today? No. MIRC. What is MIRC? Do I have any MIRC? A file called MIRC here? Okay, I don't see that, but I I see there are some file creations. Hmm. Okay, I go to this one. Sorry, this one or this one. It's comparing still. Fine. I go to network activity now. Do I see any files written? Any corrupted? Any sign for the corruption? File corruption? I don't know. Let's see. See, document settings is not accessible. Why? Maybe I go to application data. It's denied. Start menu. The access to the start menu is denied. Now it is actually corrupting the operating system, I suppose. I go to task manager, and in task manager go to more details, startup. Here I see this, but I don't see. But I see many of the stuff started behaving weirdly. I'm able to open program data, but desktop menu, you see it is not accessible. Document is denied. Start menu is denied. It is taking its time to do that. Recycle bin. So it is something. Can I access recycle bin? I can access it with this, but okay. But this one is stuck. I go to this. I'm applying filter to see the network event. I should dump this procmon outcome, and I should be loading it in this proc dot. So when I load that, it will give me the clear attack path. Yeah. And look at this, it is actually not responding. I don't know what happened. What is the weird thing happening? Look at this. Earlier, I was able to access the IDA freeware, but now I could see it is not accessible anymore because the file is corrupted. If I go to the program files directory, I see the files corrupted now. Let's see where is IDA. Here is IDA freeware, and I see this application. Is there any modification done now? Let's see. Can I access it with this? I'm able to access it with this, but the shortcut is corrupted because we could see some files of the desktop got corrupted. What about this? This one is also done, corrupted. I go to this one, program data. Maybe I go to documents. Document access is denied. All right. Like this, I access like this. And here, my pictures, my music. So all these things getting corrupted. My videos. Yeah, look at this. It's not accessible anymore. Let's see the changes done. When the change is done, and you see some sort of changes happen now. Let's see. Program data, desktop, documents, templates, start menu, application data. It's not accessible anymore. VM. Okay. Fortunately, the VM is working somehow, but definitely uh, some abnormal stuff happened. The remaining time it keep rising. Applying event filter. Let's see. Can we see this event? Tries querying Telegram. Hmm. Okay, now I have applied this filter also. Let's see. But I see only file operations here. Yeah. I guess the tools also got corrupted. Let's see. Look at this. Now the signature is now the thing is disappeared. The kappa, the shortcut is disappeared. Now it's corrupting these tools also. Process Explorer. Yeah, look at this. It's corrupted. Can I open the file location? So it's clear. It's actually destroying the stuff. Where it is referring to? C tools internals. Okay, that's the current location. C tools proc dot. C tools internals. I go to internals directory. Here it is. And look at this. Earlier we were able to see bunch of tools, but now I could see only Procmon and Zoom. What? I go to desktop, tools, utilities, sysinternals, and I see only 2 tools here. What happened to the remaining tools? Gosh, it's gone. Kappa, see the Kappa directory is empty now. Is it destroying? Is it destroying something? Because I no longer able to access this process monitor itself, because you see clearly it's a wiper. It wiped the data. It is trying to wipe the data in my system, and I'm clearly witnessing my tools, my files, one by one is getting destroyed. Forensics, Yara, fortunately it works. .NET, you see bunch of .NET tools. Earlier I was able to see the file logo. You see the location. C tools DN spy. It's no longer exist. Debuggers, WinDBG. It's still there, but it will disappear in a while. But this 32 debugger, 64 debugger is already gone. Wow. But do I have a chance to see what this malware try to report to the command prompt? You see, it clearly misbehaves. Now my VM is not functioning. It's not responding anymore. I'm not able to access it anymore. Procdot is fortunately functioning because I'm already accessing it, so it left that alone. So if I close this, I'll not be able to access that after a while. Okay, if I go to, can I open Explorer first? I can open Explorer, but I see it clearly misbehaves. And now I am clearly showing the catastrophic consequences of the Viper malware. So this is what the software they used to target the CrowdStrike victims. The threat actors started launching this specific started distributing this specific file as a solution to the CrowdStrike issue, but in fact it created a bunch of other issues in their systems. It is completely crippling the other systems as well. Very bad. You see the impact. This is the first time I executed this malware, and I see this clearly. It is actually destroying my whole system. I no longer access my tools present here. Fake net. Wireshark is functioning still now. Productivity tools, reconnaissance, utilities. I go to sysinternals and I see Procmon and Zoom it alone. Apart from that, I don't see any other tools running. And I could see it actually started posting some data to these two URLs, icanhazip.com. Let me check icanhazip.com, the reputation check. URL reputation check. Maybe I'll use Talos, Cisco Talos. icanhazip.com, I guess. Let's see. I open this. icanhazip.com. Let's see. This remnux. icanhazip.com. Fine. That one. Okay. icanhazip.com. Content categories: computers and internet. Domain: web reputation favorable. Okay. It's behind Cloudflare. Okay. Fine. I guess I should I think I don't have any other stuff to showcase because we have clearly seen the behavior of this malware. It is destroying the stuff and trying to post something to Telegram. That is apparent. That's clear. And you see now the VM is completely gone. It's not responding anymore because it is trying to destroy the system files one by one. The Viper has no mercy. A Viper has no mercy because it won't. Its ultimate aim is to crash or cripple every file on the operating system. So that's it. I think it is more notorious than ransomware, and I think I did a good job by showing this. That's fine. Maybe you should say that. Fine. I think this is okay. I have this VM now. It is not functioning anymore. I'll go and shut this down. We've seen the shutdown function, right? I think once it crippled, once it paused every file, it tried to shut this system down. I think that's what will happen next. I see utilities. I could see some utilities still now, including Procmon. Yeah, you look at this. Yeah, but the damage is already done. It's not behaving properly. All right, I'm gonna go and shut this VM down, and I'll restore this VM to the previous state so that I can restore the normal state of the VM. I'm shutting down the flare, and it's very simple. Go to snapshot manager and flare VM fresh. I'm just gonna restore to that one. Let's see, revert to Flare VM fresh. Yes, and now it is done. I go to remnux. Here I didn't do any infection. Otherwise, however, I will go and save this file somewhere. Viper capture like this. I save this file and I quit this. Now I see some Wireshark captures here in this file. So let's go and open that. Wireshark like this. File doesn't exist. Okay. No issues. I think I've shown what I thought to show. I clearly demonstrated. So we've just observed and analyzed a Viper sample. Shutdown -h now. Okay. If it is a ransomware, then it will try to encrypt that all the files on the system, not all the files, excluding the system files. It try to encrypt the other files. It will select the list of specific extensions and it will try to encrypt those files, and it will sometimes try, not sometimes, many times it will try to display the ransom note with some onion URL to the threat actor. We need to reach the threat actor over that URL, and before the encryption, they might try to exfiltrate the data to their server just to do the double extortion. That's called double extortion. They they exfiltrate the data to their server, they steal the data, and also they cripple the data on our machine. So by doing that, they prevent us from restoring the data, and also if we don't have the specific backup, then we will be in trouble. We are gone. Our business is gone. Especially imagine if you are doing a big business, involved a lot of customers, a lot of stakeholders, then at the time you will be in trouble. All the data is gone and you have no backups. So in that scenario, you don't have an option other than paying the ransom they demand, right? In recent times, if you read through the Bleeping Computer blogs, you would see some of the organization they came forward to give the ransom amount and get back their data, and they did that in past. So the ransomware market is huge actually. Threat actors earning millions of dollars in this ransomware attacks. So this is just an information beyond the topic I want to give. So that's it. Yeah, I'm shutting down this VM, and let me restore that VM to the previous state. Snapshot, reverting this one as well. All right. Now I have shown how to analyze a malware sample. I think I did the malware sample at higher level, the malware analysis at higher level. I didn't go to the too technical details. Probably once I started doing the malware analysis deeply, I could analyze every malware. I should improve my skill sets in the debugging. So that's why I didn't do any debugging today. And also I should improve my skill set in the dynamic analysis. I should know how to use various tools for the dynamic analysis. And we actually tried the Rex shot, but unfortunately I couldn't show that compared results because the operating system starts malfunctioning. So started malfunctioning. So I couldn't show that as well. But apart from that, we did some phenomenal job today. That's for sure. Yeah, I think that's it for this stream. Hopefully I came up to the stream without any topic, with no idea, but we did some productive stuff today. We did some incredible stuff in this stream. Hope you really liked it. I'll change the thumbnail of this stream because we did some malware analysis. That's the significant stuff. Yeah, I think that's it. I don't have anything else to mention. That's it. I'll end the stream here. If you really liked it, do the YouTube algorithms, like, comment, subscribe, everything. Keep supporting me. I'll be creating more videos, more streams in future. I'll catch you next time with another exciting one. Until then, I'm signing off. Cheers, and